Hello and welcome to the November edition of the Community Hangout. I'm Community Manager Matt Haynes, and with me today is Tom, one of our handy hardware engineers. And this is a really exciting hangout because this is the first one that we're doing from our brand new office. So this might be an unfamiliar room if you've joined lots of them. There's some fancy new windows on the other side, and lots more space because we're growing a lot. And we're always looking for new people, just for that shameless recruiting pitch, I guess. And so if you're interested, you should check out the job section of our website. So today, we're going to be looking at the Halloween contest, which we put out last month to challenge you to come up with spooky, scary Halloween projects and submit them to Hackster.io. And we had a couple submissions that we're going to talk about. As well as look at some new documentation on the Dev Center, and as promised, talk about BLE, or Bluetooth Low Energy, which is everybody's favorite way to talk wirelessly, except Wi-Fi.
It's everyone's second favorite way.
Everyone's second favorite way, and as it turns out, sort of a interesting, challenging way to do it, depending on what you're trying to do. So we'll get into that a little bit.
It's the right tool for some jobs.
Yeah, so we'll get into that. So I guess to start, we're going to flip over to another screen and show off a couple quick Halloween projects. If you have any questions that you want us to answer on the air, you can tweet at ElectricImp with the imp-live hashtag, IMPLIVE. Or just tweet at us and we'll see it, and we'll do our best to get those answered on air, or if we don't get to them, off air. So this was the Halloween contest we did on Hackster. We only had a couple submissions, which actually made judging fairly easy for us, I guess. One of them is a project that we've seen before, and that actually I think we showed off in last month's Hangout. Which is the photo booth, the scary photo booth that drops a spider on you to catch your reaction.
It was built by a team at Silicon Chef, and it was pretty fun to watch the judging because it was actually tweeting pictures of the judges as it was being judged.
Nice.
It was pretty fun.
So Photoboo is going to win the runner-up prize, which are some extra, or the Halloween draw prize, I suppose. There were going to be 3 projects that we randomly drew from to get dev kits. So the team from Photoboo are going to get some extra dev kits to play with and build more projects with. Congratulations to everyone on that team. We'll reach out to you. These are some of the reaction pictures.
Yeah. So Photoboo, just to kind of wrap it up again, it was a internet connected photo booth. They had the skull thing that you saw at the top of the page that has a camera in one eye. It's connected to an electric amp. The camera is actually a Radio Shack BC0706. SPY and UART JPEG camera shield that you can get, and it will take a picture on command and then serve you up the frame buffer pre-compressed as a JPEG, which they then posted off to Twitter. So this was actually a 2-part project. 1, you would sit down in the photo booth. 2, it would drop a plastic spider on your head. 3, you would make a scared face because you'd had a plastic spider dropped on your head, and 4, it would take your picture and post it to Twitter. So it was a lot of fun to watch them put this project together. It was a lot more fun to watch it be judged because we had things like this happening. And congrats to them for winning the prize.
And if I remember, there was a bunch of talk on the forum this month about that camera as well, and some of the weird kind of green-purple lines
really
that were showing up. I thought you answered those about like getting better quality images out of it.
The VCO706 camera continues to perplex people because it's not a super great camera module. There's a number of things about it that are not quite right. A lot of people have picked it up and tried to use it with just the UART, and the code that we've currently published for it is actually pretty old, and it will only work if you hook up the serial peripheral interface to the VCO706. If you try to download the frame buffer over UART, it just doesn't work, and that makes people think that they're getting the whole image, but that it's somehow corrupted because it displays the little in-browser picture that's been broken in half icon because it has a JPEG header, but the rest of it's missing.
So the trick is just to use SPY.
The trick is to use SPY, and depending on which camera module you pick up, that might mean that you have to get out the magnet wire and do a board mod to get the VCO706 to stop using SPI master mode, or it might mean that you have to manually pin out the SPI interface in the case of the Adafruit module, which does not come with the SPI pinned out. So the VCO 706 remains not a great beginner project,
but
unfortunately.
Definitely still usable.
People have definitely built stuff with it,
yeah.
But you're going to have to be comfortable with rolling up your sleeves and getting the magnet wire out, or you might invest in improving our old VCO 706 code and getting the frame buffer working over UART if you're a pretty good Squirrel dev and want some t-shirts and kit and stuff, because we'd definitely be willing to shell out some bounty money for that one.
Cool. And so the other project, this one is going to get the grand prize, is the Portable Chaos Monkey. So this is a project that uses our good old friend Charlie the Chimp.
It's one scary toy.
I love it when people hack Charlie the Chimp. It's such a great toy to connect because you can just do cool things with it. So this project basically added some. They hacked Charlie the Chimp, which is sort of the very classic symbol plane monkey toy, and they added some basic functionality to it. So if I remember right, there's an API to control the color of the eyes, to make them blink and things. There's also an API to make it clap. So just a fairly simple project, but very creepy looking, very Halloween-y. And the cool thing about this is, they sort of built this relatively generic hardware with a couple endpoints that you can sort of do anything with that you can hook it up to. So you could hook it up to like a build monitor status and have Charlie the Chimp clap whenever systems break, or their eyes change color when things are good or bad.
Yeah.
You can have it notify you for tweets. This is the start of like a lot of cool projects, I think.
Yeah. It should not be understated how creepy this thing actually does come out. I've seen one of these, and the eyes wiggle when it claps its hands. Its jaws flap. I mean, at 2 in the morning, this thing is really not just a cutesy project. It will scare the poop right out of you. It is not a pleasant thing to be around.
Yeah. So very scary. Very good choice for the Halloween contest. I think the other really great thing about this about this entry is that originally Charlie the Chimp was less scary, and they made the monkey more scary to enter it for the Halloween contest. This was a project that I think I've seen somewhere else as well. So this is really great. So you're going to be receiving our first place prize, which I think was a dev kit plus a t-shirt plus some stickers and swag. So we'll be getting in touch with you to send that off. Did you see any other cool Halloween projects, whether like with Electric Amp or otherwise?
So Twitter seemed to be pretty active, but I can't recall right off the top of my head what all of them were. We've definitely seen connected jack-o'-lanterns.
There's a couple cool projects I know of. One of them is the Halloween costume that I built.
I was going to mention that,
which we can probably send you a link to the picture of. So I built a robot costume that had some blinky lights, some EL wire, and some cool other things. But it's only kind of an imp project because the first thing in my device code is server.disconnect, and there's no agent code. So it was just because I really like the imp. I had some NeoPixels, and it was really easy to get going. But it turned out really great. It had a bunch of buttons on it. We'll pull up a picture in just a second here. So it had a bunch of buttons on it. It had a bunch of NeoPixels, and the buttons controlled the NeoPixels. So that's one of the projects. Here we go. So we'll pull it up here. So the heart and the wire around the outside is EL wire. I think everything for this project I got from Adafruit. So the EL wire and the EL panel, none of that was controlled by the imp. That was just a little control box that you can get for EL wire. And then you can see an imp board sort of in the middle, connected to some NeoPixels and buttons. So it was a really simple project. I think it was like 150 lines of code. When I have some time, I'll probably make some kind of an instructable for this kind of thing. But it's really just soldering some neopixels together and
Plugins is great because it's perfect for like just for fun projects like that, where you're like, I don't really have to integrate with anything. I don't really have to add any like crazy feature that has to behave just right. It's okay if it breaks down in the middle of the day, but it's full of blinking lights and flashy things. It's nice.
Yeah, and the other one that I saw that I wanted to mention, I'll see if I can find a picture, if a picture exists, is somebody sort of randomly tweeted, rumor has it that this person's dress at the Halloween party that they were at.
Yeah, there were a whole bunch of tweets about that.
Lit up whenever there was a tweet. Let me just see if this is actually in this video. I'm not sure if there's any pictures of it. There may be, oh yeah, I guess there's a quick video. So we can pull this up as well to watch. So this is cool. I really like this one because it's nice and simple. You know, it's a few LEDs, it's the Twitter streaming class, and basically like whenever a new tweet comes in, blink some lights for a few different seconds.
I've got some Star Wars folks. I don't think that's.
Yeah, so it's just a video, so you can just play that. So this is a few different costumes. So there we go. So that's the tweet dress, I think. And this was at a Hackbright party, I suspect. So that's really great. That's another really fun project that I was excited to see. So I think that's it for about Halloween. You saw some connected jack-lanterns, you said?
Yeah, we got some last year. We got some this year. They're always fun because you can have them turn on. You can have them react to people when they walk by.
Yeah.
We have a friend here in Sunnyvale who does an annual haunted house that's just decked out with imp. They've got singing pumpkins out front that are triggered through an imp. So they'll do a light and animatronic pumpkin show. They have all sorts of imp-connected fog machines and like a pirate that jumps out of a coffin or something like that in the backyard. So it's pretty good go-to for that kind of thing.
That's cool. And if you did build a Halloween costume with the imp or some other cool Halloween thing and you didn't enter our contest, still send it to us. We'd love to see it. You can submit it on Hackster.io or just tweet at us. And we have enough leftover loot from Halloween, from our sort of sad Halloween contest with 2 entries, that we can probably send out some extra prizes to other people who built cool projects as well. All right, so we're going to move on to some of the new documentation that Tony, our tech writer, has been working on. So this is one of the things that we've sort of been missing, that we've been trying to expand on, is sets of example code. So all of the APIs have sample code that go along with them, but one of the things we've been working on building out is building a bit more sort of very concise examples to accomplish specific tasks, as opposed to like, you know, finding some API that might be tangentially related to what you're trying to do. We're trying to build out this at the top of the sample code. You can see imp API code cookbook, and the goal with these are to have sort of really nice short recipes that you can sort of copy and paste into your code and make some small modifications to sort of make them do what you want them to do. So if you pull up, like, I think agent data persistence is one that a lot of people always ask about. So this is sort of how do you store and load data with server.load and server.save? How do you make sure that you're doing it in safe ways across agent restarts? And what are the sort of best practices for it? So this is basically a really simple example where you load the data when the agent starts.
If there's nothing pre-populated with your structure,
you pre-populate it, then you save it so that it's saved for next time. And then when you get certain requests from the HTTP handler, you update it and then you save it.
This is going to save me a lot of going back to previous code that was badly written and copying out recipes there.
Yeah. So there's a bunch of these. These also, this also links to the further reading section, which gives you like in-depth explanations with the long dev guides. And so the idea is this is sort of accomplish a task. Hopefully these will get you started on them.
Yeah. I really like the developer guides that Tony puts together, because a lot of times when I'm reading through documentation for other things that I'm working with, a lot of times all the documentation includes is just call this method with this many parameters. And that's bad enough because I don't really know what it does. If I'm lucky, I get call this method with this many parameters. Here's an example of how to use it. That I feel pretty good about. But a lot of times, even after I've done that, I'm still like, I don't really get what I'm doing.
Yeah.
Like, this works, but it's magic. It's a black box, and I don't really understand. And Tony's done a really great job of kind of breaking down those boundaries and giving you something in plain English with lots of information about how you use it, why you use it, what it's for, what are the pitfalls.
Yeah, they're a really good way to sort of go from sort of hacking around with code to really understanding what you're doing,
right?
And being able to do a lot more powerful things because you have a sort of deeper understanding of what's going on.
Like, I would consider myself to be a Stack Overflow copy-paste level C developer, in that if enough people have posted on Stack Overflow, I can probably slap something together that won't crash for 5 minutes. I feel like this is the gateway to transition from I can copy other people's code into something that does more or less what I want into I can make this out of whole cloth myself.
Yeah. And one of the things that we would love to hear from our community is sort of what other recipes or what other documentation you see that we're missing that you would like to see more of. That's something that we're always looking for. And you can post about that on the forums or tweet at us, send us an email. Let us know what's good, what's bad. We're always trying to improve our documentation. I think we've been doing a pretty good job of it, but as with everything, there's always sort of, there's a few of us and there are many of you. So we would love to hear what you guys are, what's working well in the documentation and what you want to see more of.
Yeah.
So I guess on to the meat of the discussion, which is BLE.
Right.
So BLE is something that's come up, I would say, a lot, both sort of in our community and a fair bit with some of our sort of, I guess, customers or prospective customers. And so we've published a BLE reference design.
Not quite.
We've published one.
Oh, the 112.
The BLE 112.
Yep.
Which is a somewhat expensive reference design if you're trying to mass produce it because of the cost of the 112 module, I think.
Yeah, if you're going to make a dozen of these, that's fine. If you were going to make 10,000 or something like that, you might try to find some ways to cut the cost down. But for the hobbyist community or small run prototyping or even like a first round Kickstarter, it's the BLE 112, I can talk a little bit more about, is the quickest way to build Bluetooth into your device. It's just, their software is the best.
And so I guess what we're hoping to do today in this discussion is obviously that Bluetooth reference design isn't a great starting point for everybody because not everybody has the skills or the desire to fab boards.
Sure.
And it's not commercially available. So Tom is working on a guide that we'll publish, I think, this afternoon or probably later this week. Fingers crossed, I guess.
Yep.
About how to use, how to hook up a Bluetooth, is it a BLE 112 module?
It is a BLE 112.
So how to hook up the BLE 112 breakout board, so like it on a board broken out to the imp. So basically sort of reworking our reference design backwards to a more prototype stage that will be a bit easier to use, a nice hookup guide, and then some code to get started with.
Yeah. So before I can say a little bit about what that is and kind of why we put it together, but I just want to point out that Bluetooth is the right thing for some jobs and the wrong thing for some jobs. I think there is a common misconception that Bluetooth is another physical layer protocol that I can send some bytes over like a UART and I'll get some bytes out the other side. And that is not the way that Bluetooth works.
So that's how old Bluetooth worked,
right?
Like Bluetooth 2.0.
Right. I don't know much about it because I'm actually still kind of learning as I go.
So I think old Bluetooth worked as a sort of like UART communication type channel.
Okay.
But BLE or Bluetooth 4, the low energy version, is sort of a complete overhaul of Bluetooth. And I'll let you can probably explain a little bit better the sort of overall structure of how that works.
So in BLE, in Bluetooth Smart, I'm still kind of figuring out which terms pertain to which standards because everybody's trying to have their branding be the dominant one in the field right now. But basically what you do is you set up a database that different devices can share. Like a generic attribute profile database, or GAP, is the shared data structure that both the host and the peripheral devices kind of read and write to and from. And there are a number of parameters that are standard. The Bluetooth Special Interest Group publishes UUIDs for a certain number of handles, and then everybody can implement those handles and store common parameters in there so that if I build a device that is going to look around for Bluetooth peripherals in my area, when I see those UUIDs, I can know based on the Bluetooth Special Interest Group standard, I can say, oh, this one's advertising a name, this one's advertising that it has the battery service, this one's advertising that it has heart rate monitoring or glucose level monitoring or whatever. So I can actually learn a little bit about the devices that I encounter based on that database structure and the parameters that they advertise. If I want to send data back and forth between two devices in this structure, what I actually have to do is set up a field in the database, have one write to it, and then the other one can read from the database there.
So the idea would be if I was building some obscure sensor that didn't have sort of a predefined UUID for it. I'm not sure what valid UUIDs are, but so like let's say I'm sure there's one for temperature, but we'll use that as an example.
It might depend on the context, but sure.
So if I have a temperature sensing Bluetooth device, which is probably a fairly common one that people want to implement for sort of home automation, local network home automation type system,
yep.
My Bluetooth temperature sensor would write a field to its database to say this is the value of the temperature, and this is the UUID that goes along with temperature values. And then somewhere else I would have probably something hooked up to an imp that would read from that database to say, what's your temperature? Or like, I see you have a temperature field, what's your temperature?
It's a little different than that because there's not a device sitting in between the client and the host, right? One doesn't have to write and the other one has to read because there's no one in the middle to hold the data in the meantime. So I can give you an example. I've been working with, let me just pull this up. Broadcom has these wicked SenseKit tags. Here it is. There's a little thing you can get for I think like 20, 35 bucks, and this has a bunch of ST micro parts in it. It's got an accelerometer, a temperature sensor. It actually has a whole IMU. So you've got a gyro, magnetometer, accelerometer. You have temperature, humidity, and barometric pressure. It's a fair little bit of kit. And what this will actually do is it advertises, hey, I'm here. Whenever you press the button, it'll advertise for a certain amount of time. With that advertisement, it says, I have a name. That name is Wicked SenseKit. So I've been working on an application that looks for anything advertising the name Wicked SenseKit, and if it finds it, it connects to it. Once I'm connected to it, there's a number of things that are set up in the Wicked SenseKit's GAT database. So it has a characteristic configuration descriptor is what they call it, which is basically just a slot in the table you can write a 1 or 0 to turn notifications on or off. If I turn the notifications on, then the Wicked Sense tag will start sending me, the host device, the central device, will start sending me notifications at regular intervals that carry data like the humidity, the temperature, the barometric pressure, and the IMU data. Data streams in much, much faster because it changes more quickly. The temperature data updates about once every second. If I ever get tired of talking to it, I can turn the notifications off by writing that client configuration descriptor in the SenseKit tags GAT table, or I can just disconnect from it, at which point it'll go to sleep and stop advertising until somebody presses the button again in order to save power.
Is the button the only way that you can get it to advertise all of its information?
Right. It is in this case because that's the way that this device is programmed. But actually, Broadcom has gone ahead and published the code that's running on the Wicked SenseKit tag. And if you download their IDE, you can actually reprogram it.
Oh, cool.
It's just a stock chip running inside there. So, and we're actually working on a reference design that shows how to integrate one of those chips with an imp. And that's a really interesting design because not only can you talk to it back and forth, but you can also overwrite the code running on the Broadcom Bluetooth chip by sending a binary image to the imp. The imp puts it in reset, rewrites its image, boots it back up.
Right. So similar to what we've done with the Arduino Shield.
Yep. Or like the STM32 or a number of other processors that we've played around with. And that's great because it means you can do in-field updates without having to have like a phone walk by to do a Bluetooth over-the-air firmware update. You can just push it from the internet and all the gateways will update. But I feel like I've kind of veered off course here a little bit.
So I guess this is good though. These are all kind of things that you can do when you pair an imp with BLE. Right.
So why might you want to do this in the first place? What is an application where BLE is a good choice?
Yeah.
Right. A lot of people have built the temp bug instructable. Do that. Let's just pull that up. So a lot of people have seen this before. This is a little internet connected. It's built with an imp and a battery and a thermistor. It's a temperature sensor that sleeps all the time and wakes up every 15 minutes and posts data to Zybly, so you can make a graph out of it. But what if I wanted to put 100 of these in a room, like every 2 feet? And what if I wanted to take the data more often than that? I probably don't want to hook up one imp per. I probably don't want to hook up one imp for every 3 or do some crazy huge multiplex thing. What if I want it all to be totally wireless and not too complicated? Bluetooth might be a good fit for that because I can put many Bluetooth devices running on little coin cell batteries that the imp can't run off of because its instantaneous current draw is too high. And I can have all of those send notifications to one central Bluetooth device that talks to an imp so that it actually acts as the backhaul for the entire personal area network.
So it's basically creating a tiny like Bluetooth network, and then the imp acts as an internet gateway to send it to wherever you want.
Exactly. So that's a really good fit for imp and for Bluetooth. Bluetooth can be really great for other projects too, like if you have a battery-powered device that can't sit around and listen for notifications all the time, say like a connected lock or something like that. And you want that device to only be awake and ready to receive notifications when you're nearby to save battery. You could have a Bluetooth device or like a Bluetooth gateway inside the house that listens for your phone to come by and advertise. And if it sees it, then it could go ahead and wake up the lock.
Yeah, that's sort of the premise behind Lockatron, if I remember right.
I don't know what I can say about their architecture.
Yeah.
But it's an important part of their solution because of the geofencing.
Yeah, I know they do both sort of like Bluetooth and Wi-Fi things.
Right.
So.
Yeah, the Bluetooth acts as the low-power listener in a lot of applications like that one.
Yeah. So is that sort of the basic premise of iBeacons then? Is you have somebody broadcasting, and when you walk by, you do something interesting with it?
So iBeacons are a little different because iBeacons aren't two-way communication. They're kind of like Bluetooth that's been cut off at the knees because they have only one very simple purpose, and that's just to advertise. In a lot of Bluetooth devices, like say the Wicked Sense Kit, there are 2 phases of communication. There's the advertising phase where, hey, I'm here, I'm a Wicked Sense Kit, I'm a Wicked Sense Kit. You can connect if you want. And then once I've connected, I can communicate back and forth. I can send information that I'm taking from my sensors. I can change, as the host, I can change the SenseKit's client configuration descriptor to subscribe to notifications or unsubscribe. So there's those 2 phases. An iBeacon doesn't do the second one. All it does is advertise. And the reason for that is mostly for things like navigation or retail settings, where your phone knows that if it walks past an iBeacon advertising a certain UUID, that iBeacon is at this specific geographic point. It can check with its own data connection to figure out where you are and then deliver some targeted advertising or some targeted navigation help or something like that.
Right, so for iBeacons, you need sort of prior knowledge of the IDs in order for them to work.
iBeacons are useful if there's a database that everything that walks past the iBeacon can query to say, where is this iBeacon and why do I care?
Yeah, so the way iBeacons work is the iBeacon basically says, hey, I'm iBeacon ABC123, and you're running an app on your phone, and the app says, hey, I know iBeacon ABC123 because it calls out to a service, and it gets a response back that says, hey, you should advertise that these headphones are only $10 instead of $12.
Right, and we've actually seen some people do some interesting things with iBeacon type setups, like in a room, right? If I put 3 beacons down. They don't have to be iBeacons. If I put down 3 devices that only advertise, then I have a phone. The phone walks through the room. The phone can see all 3 of the beacons, and it can see the relative power of each of them. And you can actually trilaterate. It's not triangulate. It's trilaterate because you're actually measuring the lengths of the triangle legs to figure out where in the room you are relative to those beacons. So it's an interesting thing you can do.
Cool. So let's move on to the actual example that you've been working on, and show people how they can start playing with Electric Imp plus BLE.
Sure. So to kind of walk it back here, we were talking about the BLE 112. That's the Blue Giga part. This one's probably the easiest one to get started with because it has software on it already, and it's easy to write software for it. The BLE 112 actually has a way to work with it called BGAPI. There's a stock image that runs on the module, and basically there's a set of commands that you can send and receive over the UART, like a host control interface, to have it do different things. Like you can say, scan for this long. You can say, connect to this device. The other half of that is the bglib, which is a C standard library that implements all the commands that are in the BGAPI. And we've done a scroll port of bglib, so that if you hook up a UART to a BLE 112 to the imp, and you put this class in, and you run the stock bglib BGAPI image on the BLE 112, you can do all the things you could have done with the bglib C library. So we kind of cooked up a little example with that.
So wait, does that mean you can sort of reprogram it on the fly?
No.
Correctly, or you can give it like scripting language type commands to do things?
No, it's a little different than that. So the BLE 112 can be programmed to run standalone images, or it can be controlled via BGAPI. In this example, we only deal with the BGAPI. And what's interesting about that is that all of the application logic is on the side of whatever device implements the bglib, which means that all of the application logic for this project is on the imp side.
So this is almost does the device kind of act like an agent for the BLE device? So the BLE device has some stock code with like, it knows how to handle certain commands, and then your device sends commands to it over UART to get it to do those things? Yeah,
that's about right. So you're treating this BLE 112 module like a normal peripheral. You're treating it like you would a sensor or something like that. You could just send a known set of commands to. Cool. It's a pretty powerful peripheral that way,
right?
But that's the way that it works. So in this example, what we actually did is we told it, just go ahead and scan, and every time you see something you haven't seen before, or you see something you've seen before that's power levels changed, report it back to us, the imp. And every time the imp gets a scan back, or it gets an advertisement back from a device that's walked by, it posts that information to Firebase, where we keep track of all the devices that have walked past that location.
Okay.
And then once we have all that information, we can just throw it into Google Charts and make a graph of the relative signal strength of all the devices that have walked past in a certain window of time.
Oh, wow.
Which is kind of fun, yeah. So you can actually watch, when we first set this up, we put 3 or 4 of these in the office, and we could watch where Hugo walked around in the office because he wears one of those Nike Fit bands on his wrist, and the rest of us don't.
Right. So I often wear a Pebble, so you
probably can track you too.
You may have been tracking me for a while.
Yeah, we'll have to go consult the database. So this is all, we've got all the code up for this, and this is what the tutorial is going to do. It does one other thing, which is on command, you can actually do GAT discovery on one of these client devices that's walked by. And that is where you say, hey, you, advertising over there, connect. You connect, and then you ask it, give me the UUIDs of all the services that you're capable of providing.
And the services are basically bits of information that they can return from the database?
Services are things like device identification. So it can tell you its manufacturer name, its model number, things like that. It could be things like temperature service. It could be things like battery service, where you can read its battery level, or stuff like that.
Mm-hmm.
So, the Nike Fit might be able to tell you how many steps you've taken in the last day or something like that if you connect to it. It'll advertise those services. So you can connect any of these on command, do the discovery, and kind of learn a little bit more about what these devices are that are walking around your environment. And this tutorial is actually really easy to build because you can buy a BLE 112 breakout board for $50 that has everything you need right on it, and you can hook it up with 7 pieces of wire.
That's a lot of wires.
Yeah. So it's a UART a reset line, power, and ground.
Okay.
And that's it.
So you do have some free pins then for or you have one free pin it looks like using in April.
Yeah.
If you used a module breakout, you'd have a few more, I guess.
Right. Right. And this is actually using a flow-controlled UART, but I'm not going to disappear down the rabbit hole of talking about UART flow control versus not UART flow control.
Sure. And so I guess not having extra pins is probably not a big deal because the main idea behind this is that you have one imp acting as a gateway, and it's probably not doing much else. It's basically like a Bluetooth modem in some respects.
You had one job. It has one job.
And then you have a bunch of other BLE devices that are hopefully not $50 plus anything else. That's just sort of either pre-built BLE module sensor type things or other things that you've built.
Right. That's actually a really good point. There's a lot of off-the-shelf stuff you can buy. There are things like iPhone accessories that you could just kind of hack on without having to take them apart or wire anything up or kind of, you could just spoof a phone or you could just connect as a host. Right. A lot of these things are just totally happy to do that.
Yeah. So you can create sort of your one modem with the imp that does the interesting things, and then just get a bunch of like weird BLE accessories that provide information and just stash those all over your house or wherever.
And there are a lot of people that are a lot smarter than I am that are doing a lot of things with the BLE 112 and writing about them in their blogs, which means that if you put this together and you implement bglib, you can do basically squirrel port of the stuff that they're hacking around on and connect it to the internet.
So with this, you said there's sort of the discovery service where you can just say, connect to this device and give me all of the services that you have. So I'm imagining an imp with a BLE 112 module breakout on it and like war driving BLE. So you have it disconnect and just have it like scan for BLE devices, grab the IDs, and then you have this like scary thing that just like collects IDs and services that it has, and then occasionally tries to see if there's any open networks around, and if there are, it just dumps everything. Maybe it scans Wi-Fi networks at the same time, so you can geolocate where you found things. That's suddenly a very scary prospect.
The interesting thing about Bluetooth is that a lot of the services that you can pick up and work with are not too scary on their own just yet. I mean, some of them are a little close to home, like I can walk past and get someone's heart rate monitor to tell me how fast their heart's beating.
Right, because no one's really securing these things right now.
Bluetooth has some substantial security holes. So yeah, but a lot of these things are not like I can turn off a power station yet. So
although presumably you would probably not want to have a power station have its control through BLE.
That would be a very strange architecture that I would not recommend.
Yeah. Okay. So what kind of off-the-shelf things? What other off-the-shelf things can we do with this code that we've written?
So this is the only example that I've presented. I've been spending a lot of time actually with another Bluetooth module that hopefully I can present maybe next month once we have a little bit more to talk about. It's a totally different architecture for how you do this, but there are some people that are already developing with it, so they might be interested to see.
And the big advantage of that one, I guess we won't go into specifics for
it. We'll talk about it later.
Much cheaper, much lower power, or just sort of cheaper?
It's just cheaper.
Cheaper, smaller.
It's cheaper and architecturally different.
Okay.
This is the one that I recommend for people that are interested in getting started with Bluetooth because it's the most bang for your buck.
Yeah.
You can do the most stuff with it right away. You'll have a lot of fun and not rip your hair out all the time.
Cool.
And then there are other things that are a better fit for different kinds of projects. If you're trying to like go commercial or something like that, you can talk about those
some other time
when we work on them more.
Yeah.
But yeah, this is a great part. I recommend. So we actually walk through like how to pull in the code, how to configure the example, how to power it all up after you've connected it, and a little bit of additional reading that you can check out once you're done. But it all really comes down to just wiring up like this and copying the code that we've made. And the code's pretty darn fresh, so if you find bugs or have troubles working on it, that's the sort of thing that earns swag when you point it out or help us fix it.
Yeah, this is one of those, this port I don't think has been fully tested against the breakout.
Nope.
So if you do find bugs and you submit pull requests, probably either for documentation for hookup, which will probably be okay, but there might be some tweaks that need to happen, or code if you submit pull requests that sort of if you submit pull requests, we'll definitely send out some swag of some kind.
Do we have comments on community blog posts? Is that a thing?
Yep, there's comments.
So this is going to go up, this tutorial is going to go up as a community blog post, and if you build it and you want to talk about it, comment on it, and if you've got questions or point things out or can help us continue to make our documentation and our tutorials better, that's, I think, an opportunity to get some stuff.
Cool, that's great. Any other final thoughts on Bluetooth or this project or anything else?
I think I still have a lot to learn before I can talk about things that it does really well and things that it doesn't do really well. But I think my parting thought would be throw this together, because even if this particular application isn't one that jumps right off the page at you, it's really easy to build and it's really generic, and the BGLib port is really generic, and your application could do all sorts of things that this doesn't do, and its code changes.
Should the BGLib work for any BLE device? That's one thing I'm not super clear on. It needs to be something that has BGLib implemented.
Yeah, let me just reiterate one more time. So the BLE 112 is apart from Blue Giga. That's where the BG comes from. There are 3 different B prefix things that you need to be aware of, and I linked to them in the post, so you can, there's a post that explains what they all are. There's BG script, which is a scripting language you can use to write standalone applications on a BLE 112 that we don't cover in this tutorial.
And for that, you need like JTAG headers and like.
You can actually build the image and just DFU it on because it's 2014.
Oh, nice. Okay.
Yeah, JTAG is not a spring chicken anymore.
Yeah.
So that's BG script.
Yeah.
There's BG API, which is the API over the UART that this part advertises when it's running the BG API stock image from Blue Giga. And there's BGLib, which is the C standard library that other devices can implement to talk to the BLE 112 over BG API. And the BGLib is the thing that we've done a swirl port of to run on the imp. So BG API, BGLib are 2 parts of the same protocol.
Gotcha. So those 2, you need one running on the BLE device or the peripheral,
right,
and then the BGLib running on the or the BGLib port running on the imp device to talk to it.
BGLib or BG API image on the BLE 112, BGLib class in your imp firmware, and then you can talk Bluetooth to Bluetooth peripheral devices.
Cool. Yeah, that's exciting. I mean, Bluetooth is sort of not what we specialize in, obviously, but it is
an important part of this nutritious breakfast.
It is an important part of this nutritious breakfast. So it's exciting to see development, and especially sort of community-focused development, so that people can sort of get hacking with it a lot easier.
Mm-hmm.
So I think that's about it for this Hangout. Our next one is going to be sort of around the corner. It's going to be a little bit later in December, just because of some events that we're supporting at the start of it. So we're going to be heading off to RobotsConf, which is a big turn software developers into hardware makers conference at the start of December. So our next Hangout is going to be December 15th, and we're going to switch from the morning to the afternoon. We're going to sort of flip-flop back and forth so that it's a little bit easier for people some time zones versus other, and try to share that love. So it's going to be December 15th from 1:30 to 2:30 Pacific time, and we'll create a link and an event and everything like we did last time. I don't think we have any topics yet, so if there's anything in specific that you want us to discuss, let us know, and we'll see if we can fit that onto the docket. So, cool. Thanks for coming by. It doesn't look like we got any questions, so that makes it easy. Although somebody did tweet that Adafruit now carries 2 and 9-pin 0.1 terminal blocks for the April board.
Oh, nice. So you can put some header pins on your April when you buy it.
Yeah.
Yeah.
You can get the screw terminal ones.
Oh, cool.
So you can screw things in.
No soldering, and you can take it out and build it into something else later. That's a good way to split the difference.
Yeah, that's a good way to sort of, you want semi-permanent projects but you don't necessarily want to solder.
That'd be worth getting once and seeing if I use it more than once.
If you use your April more than once?
Yeah.
Yeah.
Yep.
So check that out if you're interested. We retweeted it, so it's up on there. Thanks again for stopping by, and we'll see you next month.